Okay, let's give you guys some more practice. So here, differentiate this. Find dy by dx of this. And bear in mind that this is an implicit equation here because you've got a y buried along with the x on this side and you've got a y over here. So this is an implicit equation. Well, anyway, differentiate this. Find dy by dx. Okay, so press pause and have a go. Okay, so to do this here, visualize this as one bubble here, and then and visualize this as another bubble. Now natural log both sides. Okay, so that will then give you this. So basically, natural log both sides. That will then give you this. Okay, so you've got natural log this. Okay, and then hit and then visualize this as one bubble, and this is another bubble here. So when you log log of AB, that's the same as log of A plus log of B. Okay, so that will basically break these two up. So that will then give you this and this. Okay, and then look at this bit here. Now at the moment you've got the natural log of this whole bubble here, but then visualize as this. You've got one bubble here and one bubble here. So that will then you can then break this into this and then this into this. And bear in mind that this here is a constant. It's just a number. So when you differentiate it, it will be 0. It's just like, well, if you differentiate 3x with respect to x, it will give you 3. But if you just differentiate a constant, like this here is just a constant, it's just a number. So when you differentiate this, it will be 0. Okay, so well, anyway, just bear that in mind later on. So here, break these two up. This here will give you this, and this will then give you this. Okay, so now hang on. So that will then take us to here, and now you've got a log of e here. These two will kill off each other, giving you y. Okay, and then now differentiate. Well, when you differentiate this here, imagine this as being inside a bubble here. Okay, so when you differentiate this, it will be 1 over the bubble itself, and then you go to times with the differential of the bubble itself, which is 1 over y. And then because y is a function of x, you go to times by dy by dx. Okay, so this bit here, we've done this many times in the past. Okay, so when you differentiate this, it will then give you this, which is this. Okay, so hang on. So when you differentiate this, it will then give you this. Okay, differentiate this, that will give you nothing. So we can forget about that because this thing here is a constant. Differentiate this, you will get 1, but then you go to times dy by dx. So yeah, you go to times dy by dx because y here is a function of x. So when you differentiate this, it will give you this. Okay, so differentiate this bit, it will give you dy by dx. Okay, so now you've got to differentiate this bit now. So imagine this as being in a bubble here. When you differentiate this, it would be 1 over the bubble, and then you've got to times with the differential of the bubble itself. So when you differentiate cos of x, that will give you minus sine of x. Okay, so that will then give you this. Okay, well, differentiate this, it will give you this. So now it's just a matter of tidying it up. So hang on. So yeah, so tidy up. Top times top times top, bottom times bottom times bottom here. So that will then well, actually just merge these two together. That will then give you this, and leave dy by dx alone, and then this gets multiplied to the top, giving you this. Okay, you've got a minus here, and then you've got a yeah, you've got a minus here, so that gives you this minus here. Well, anyway, tidy this up. It will, hang on, let me think. Oh yeah, so now you've got one block times another block. That equals this block, take away this block here. We want to get dy by dx on its own. So move this, well, take away dy by dx from both sides. So from here, that will then take you to here. So basically, this block here remains the same, but then we'll take we are pretty much moving this block over to the other side here. So take away this block from both sides. Okay, that will then give you this. Oh, by the way, this bit here, remember remember our unit circle here has a radius of 1. Well, the height here is sine of x, and then this length here is cos of x, and tan. Don't forget, tan is this thing here. Tan would be sine of x divided by cos of x. Sine of x divided by cos of x. So this bit here is tan of x. Okay. Well, anyway, this then becomes yeah, and then if you look at this, dy by dx is in common. Well, at the moment you've got one block. At the moment you've got one block, and then you've got another block. So factorize the dy by dx. That will then give you this. Okay. So now you've isolated the dy by dx. Okay. And then now divide. So at the moment you've got this times this block here. So divide both sides by this block here. Okay, so that will then sorry, hang on. Before you do that, before you divide, merge. At the moment you've got one fraction, take away in away another fraction here. So merge these two together. Okay, so merge these two fractions together here. That will then give you this. Okay, so now you've got one block times this block here. Now you want to get dy by dx on its own, so kill off this block here. So divide both sides by this block here. Okay, so that will then give you this. But then whenever you divide a fraction, that's the same as you timesing the reciprocal of this thing here. So you turn it upside down basically, this bit here, and then this bit here gets multiplied to the top. That will then give you this, and then dy by dx equals this. Okay.